Here we go with the last section in this unit. We are going to talk about implicit differentiation, find derivatives. So we use basic techniques for calculating a derivative dy dx if we have x being given in terms of, y being given in terms of x as a formula. For example, x to the third plus 1 equals y. But you'll see a lot of examples where we have something defined like this example here. So y to the fourth plus xy equals, this case, y is defined implicitly. So like y is not easily separated out of that function. So we need to use implicit differentiation to be able to find the derivative of this because we can still look to see what's going on with the tangent line. So here is where we're at. We're going to use this derivative here to find the slope of the tangent line at the point. So when we have implicit differentiation, you'll notice you'll have the x and y there. To find the slope of the tangent line, we're going to really just plug in what we have. So we're going to do x, negative x, which is 3/5, divided by y, which is 4/5, and then simplify that. We get negative 3/4 for our slope of the tangent line. Okay, so the derivative was already taken. To find the slope of the tangent line there, we're going to plug those values in, and we're good. Okay, we're going to use that quite a bit. Keep that in mind because we don't need to simplify a lot if we're finding a value at a point. We could just plug things in and then solve afterwards. Okay, so next, find the equation of the tangent line at the point p equals 1, 1 on this curve, which is the original function. So we're going to use the same rules. The derivative of y to the fourth is 4y to the third, but we have to use the chain rule here and multiply by the derivative of y, which is just y prime. I will often write dy dx just because it's a habit. Y prime is enough, it saves you time. Okay, for the second part, we do have to use the product rule. So we're going to do 1 d2 plus 2 d1. And then we have the derivative of x to the third, which is 3x squared. The derivative of negative x is 1, negative 1. And the derivative of 2 is 0. Now, from here, we can rewrite this so we have the derivative, and I'm going to show you those steps there in a second. Or you can plug those values in and then find the slope. But this is going to show up in a multiple choice test, part of the test, where I need to keep these two on one side and move everything to the other side so that I can factor that out. So I'm going to subtract y from both sides, and I'm going to factor out the y prime from the other two terms. So I have 4y to the third plus x, and then I moved this over, so I have 3x squared minus y minus 1. Now to figure out y prime, we're going to divide by that whole thing here to get y prime alone. So that is actually our derivative, this fraction here. So we have 3x squared minus y minus 1 over 4y to the third plus x. Okay, now at 1, 1, we're going to find the slope by plugging in 1. So I have 3 times 1 squared minus 1 over 4 times 1 to the third plus 1. So 3 minus 1 is 1, and 4 plus 1 is 5. So our slope is 1/5. We have our point. Write your tangent line. And you are good. Okay, rules are the same. If you're taking the derivative of a term that has y, just make sure you do the chain rule and multiply by y prime. Okay, next one. Same thing here. The derivative is going to be e to the x minus y times the derivative of that, which is 1 minus y prime. Okay, you don't have to use a product rule or anything there. Equals 4x minus 2y times y prime. Now, instead of rewriting this, they just want us to find the slope of the tangent line. So I'm going to go ahead and plug in 1 for each of my variables. So I have e to the 1 minus 1 times 1 minus y prime plus 4 times 1 minus 2 times 1 times y prime. And the reason I'm doing that is it might make it a little bit easier for me to simplify. So e to the 0 is 1, so I really have 1 minus y prime here, equals 4 minus 2 times y prime. So if I move that y prime over by adding 2, so negative 1 plus 2 is y prime, and then I'm going to subtract 1 to get 3. So we just found that our slope of the tangent line at the point 1, 1 is 3. Okay, last one. Same idea here. This is a big problem. Do not try to solve for the derivative. Let's just plug things in. So the derivative, 1 times d2 and then we have to use the chain rule, so we have y prime plus 1 plus 2t, okay, plus 2 times d1 equals 3t squared. Okay, this is a huge mess. Let's plug in everything we know and see what happens. So I'm going to highlight here. Anywhere we see y, we are going to plug in 5 pi over 3. And make sure it's y and not y prime. Sorry, 5 pi over 2. And then anywhere we see t, we are going to plug in 0. So we have 0, 0, 0, 0, 0, 0. And I'm going to go ahead and simplify this right away. So this is 5 pi over 2 times negative sine. These are zeros, so those don't matter. So of 5 pi over 2 times y prime plus 1, and then this is 0, so we don't have to worry about that, plus cosine of 5 pi over 2, and then these are 0, so we don't have to worry about those, times y prime equals 0, because this doesn't matter. Now, you need to know 5 pi over 2 is the same as pi over 2. So pi over 2 is up here. We have the point 0, 1. So sine is 1. So this is really a negative 1. So negative 5 pi over 2 times y prime plus 1. Cosine is 0. So we have 0 times y prime, which is just 0. So we really just need to solve here. And I'm going to distribute to do that. So I'm going to do 5 pi over 2 times y prime minus 5 pi over 2 equals 0. And actually, I didn't even need to do that, but I'll show you why in a second. 5 pi over 2 times y prime, negative 5 pi over 2, equals 5 pi over 2. So when I multiply by the reciprocal here, I end up getting y prime equals 1. There's our final answer. Sorry, negative 1. Okay, like I said, that one's a monster of a problem. Be really careful with your chain rules. Okay, summary here. Take the derivative of every term and then go from there. And then I did alter this a little bit. I took number 46 out. Go ahead and get to work. If you have any questions, let me know. Have a great day.